we go. Hey, we got to fade that out better. That's okay. That worked fine.
I didn't even do that time. You didn't come back and go, blah, blah.
I think we're good. Looks like we're up live on Facebook and on YouTube. Good evening, everybody. All right. All right, let's get started, I guess. So good evening, everyone, and happy Valentine's Day, first of all. Welcome back to our Sunday night offering of Astronomy Outreach, the Sunday Night Astronomy Show. Thanks for joining us on this Valentine's night. Probably all the single folks out
reminded
there.
me and I forgot.
Oh, there you go. Now you're single as well.
Yeah.
All the single folks out there may be tuning in tonight. Oh well, we'll take both. First of all, I'd like to welcome back our regular co-host, Royal Astronomical Society of Canada member, Mr. Paul Owen from the Moon Shadow Observatory in Hampton. Good evening, Paul.
Hampton. Hello, everybody.
And we'd like to welcome back Mr. Mike Powell from the PFO Observatory here in St. John, New Brunswick. Welcome, Mike.
I'm this way.
My screen, you're this way. I guess I should turn on the phone and see which way we are.
Okay. So
I know eventually I'm headed that way.
I guess it's the Drunk Brady Bunch show.
Yeah.
All right. Well, tonight then we have another full show planned out for you. Tonight's show is going to be mostly just one topic tonight, our constellation of the month, which is Cassiopeia. Last month we talked about Orion, which was a great topic. We're glad to get that information out to everybody. But tonight it's going to be Cassiopeia. So we're going to start off a little bit with a presentation about Cassiopeia, its story, how it got its name, how to locate it in the night sky, and some of the best treasures that it contains. After that, Mike's going to offer us up some information on how to find those special treasures, including binoculars and including using binoculars, or a small telescope. And then Paul is going to offer us up some info on how to capture those targets, but mostly he's going to show us some photos of what he has captured in that area. We'll also have an interesting Rosanna's Fun Facts for you later on to share with you. And we're also going to take some time to share your wonderful photo submissions that you've submitted through the week. And of course, we'll take all your questions on telescopes, binoculars, and stargazing and more. So sit back and enjoy, folks. Remember, this is a family-friendly live broadcast. So if you have any questions about the night sky, we're happy to try and answer them here for you. So I guess we're going to get started with a little bit of information on the constellation of Cassiopeia. We'll say hello to everybody out there in Facebook and YouTube land. And I'm going to try to bring up a presentation here for you. I just added my 6th monitor, so I got to find out where my mouse is now. Here it is. Cool. First of all, I'm going to have to share my screen. And I'm going to select number 3, I think. Hello. That should bring us up. Okay, now if I can get the presentation going. Bear with me. Show from the beginning. And of course it popped up on the wrong screen, so let's bring it over here.
Too many screens.
Too many screens.
I got 6 screens, man.
Okay.
Great. Try one more time.
Which one do we use?
We might have to bring it down this way.
It worked when we weren't live.
Yeah, it did actually. From the beginning. Let's see where it goes now. Oh, nope. Still one on the wrong screen.
I see it. It's up.
It's up. Yeah,
It's up, and it's up on Facebook.
It's up on the wrong. It's the wrong one up though.
It says Cassiopeia. We got the right constellation.
It does say that. Hide presenter shoe screen. I can't move it over. Okay, we'll have to do it this way, I guess. Because I'm not able to fill the whole screen with it. It wants to pop it up on a third screen. Yeah. Oh, anyway. I think we can get back to it.
Oh, PowerPoint. Yeah.
Yeah. When I open it up, it won't let me put it on the proper screen. Unless,
Okay.
oh, hang on, just a sec. I think I can do that. Just a second. Bear with me. If I stop presenting and I try to present from the other screen, maybe that'll do it. Present now from entire screen, and I think that's screen number 2. Let me see if that screen pops up. Nope.
Okay, I see your live screen.
Yeah, no, it's not going to give it to me. Isn't that a so-and-so?
Yeah.
I cannot drag it over and drop it either. Just bear with me for a sec.
No problem. While you're looking that up, hello to Julie and Jamie and Brad and Emma and Amber, Alan, Lisa Ann, Eve. Am I missing anybody? No, I think I got everybody so far. So hi everybody out there.
What's everybody on Facebook?
Yeah. I'm not sure who's on YouTube. I haven't got that up, but there's Renat. Oh, speaking of which, Chris, while you're looking for that, I've actually met Renat the other day and got her that planetarium, planisphere, I guess you call it.
Oh, yeah, yeah.
Okay.
And I got something for you guys, and one for you, Chris, and one for you, Mike, and Renat.
Calendars.
A nice calendar.
Oh, beautiful.
2021.
Back Bay.
Yeah, one of her paintings on it, and all the months of the year. So when I run into you guys again, thank you to Renat, and I will make sure that you both get one.
Hang on, Paul.
Well, yeah,
Show
thank
that
you very
again.
much.
Show that again, please, Paul. Could you show that again, Paul?
Oh yeah,
I,
sure.
I had the screen covered up. Sorry about that.
Yeah, I'll pull back. You can see the whole thing.
Awesome.
Yeah, so it's absolutely one of her beautiful paintings, and of course all the months of 2021, and yeah, from Back Bay, New Brunswick, beautiful place. That I think they still have the foghorn. I think I could be wrong.
Gorgeous.
Okay.
I'm down there.
Okay, we'll go back to
Or it
presenting
might be
again.
just a horn that attached to their leg, foghorn, leghorn.
Wow.
I mean, an old Chevy truck.
Hey, Gino.
Give me one more time to bring it up. There we go. Yeah, so it's going to bring it up here. So I guess we can still see it. Anyway, our talk tonight is on Cassiopeia. And a little bit about it. Cassiopeia is the 25th largest constellation, contains 8 named stars. One of the 48 constellations listed by the 2nd century astronomer Ptolemy. It's easily distinguishable due to its distinctive W or M shape, depending on what time of the evening you're looking at it. And it is circumpolar, which means it's visible all year round as well. So here's where we're looking. Here's our winter Milky Way. There's Orion sitting over here. Here's Taurus the Bull. There's Perseus, Auriga, and then off to the right, I guess over to the northwestern part of the sky. This is looking west right now, so over the northwest. But we can see that it sits right into the middle of the winter of Milky Way. So it is the forefront in the foreground, and the Milky Way in the background, of course. But it's a very rich part of the sky, is what I'm trying to get to, I guess. So. Now, in Cassiopeia, in mythology, Cassiopeia was the wife of King Cepheus of Ethiopia. Once she boasted that she was more beautiful than the Nereids. The Nereids were the 50 sea nymphs fathered by the Titan Nereus. They were enraged by Cassiopeia's comments and appealed to Poseidon to punish Cassiopeia for her boastfulness. Poseidon was married to one of the nymphs, Amphitrite. Now the sea god obliged and sent Cetus, a sea monster represented by the constellation of Cetus the whale, located in the same region of the sky, to ravage the coast of Cepheus's kingdom. Cepheus turned to an oracle for help, and the oracle told him that in order to appease Poseidon, he and Cassiopeia had to sacrifice their daughter Andromeda to the sea monster. Reluctantly, they did so, leaving Andromeda chained to a rock for the monster to find. However, she was saved in the last minute by the Greek hero Perseus, who happened to be passing by. Just happened to be passing by. And he saw Andromeda and rescued her from the monster. Well, Perseus and Andromeda were later married. At the wedding, one of her former suitors, named Phineus, appeared and claimed that he was the only one who had the right to marry Andromeda. Well, then there was a fight, and Perseus, desperately outnumbered, used the head of Medusa, the monster that he had recently slain, to defeat his opponents. One look at Medusa's head turned them all into stone. In the process, though, however, the king and queen were also killed because they did not look away from the monster's head in time. It was Poseidon who placed Cassiopeia and Cepheus in the sky. Cassiopeia, the myth goes, was condemned to circle the celestial pole forever, and spends half of the year upside down in the sky as punishment for her vanity. She is usually depicted on her throne, still combing her hair. True story.
Yes.
True story, I guess. Yeah.
So Medusa got them all stoned.
She did.
Yeah. It was right around Woodstock.
Yeah.
Everybody was stoned.
All right, so Cassiopeia does have many beautiful features. Messier 52 and Messier 103, those are two Messier objects in that area, both bright open star clusters. The Heart Nebula, Paul knows all about this one. The Emission Nebula, located at approximately a distance of 7,500 light years from Earth, known for its intensely red glowing gas and dark dust lanes, forming a shape that resembles a heart. The Soul Nebula, that's another one. That's a vast star-forming region illuminated by the light of the young stars surrounded by star-forming clouds of dust and gas. And Cassiopeia A, a supernova remnant that first became visible from Earth about 300 years ago. Some of the other features that are in that area, it's a very, very busy part of the sky. The PACMAN Nebula, and that's an emission nebula, given the name due to its striking resemblance to the popular video game character. The White Rose Cluster, which is a great Valentine target, I guess. A beautiful open star cluster. An open star cluster is a group of up to a few thousand stars that were formed in the same giant molecular cloud. Now, the White Rose Cluster is also known as Caroline's Rose, after Caroline Herschel, the British astronomer that discovered it. And as well as several beautiful double stars, such as Gamma Cassiopeia and Delta Cassiopeia, along with the yellow hypergiant Rho Cassiopeia, and of course NGC 457, the ET cluster. Talking a little bit about Cassiopeia A. Cassiopeia A is a remnant of a supernova explosion caused by the collapse of a massive star. The light from the event is estimated to have reached Earth between 1662 and 1700. It's the strongest source of radio emission in the sky beyond the solar system. Although the explosion must have been very powerful, no contemporary record, aside from a possible sighting by English astronomer John Flamsteed in 1680, exists of it having been observed. So the explosion may have happened behind an interstellar dust cloud. It's about 11,000 light years from Earth, and at the center of the remnant is a neutron star, which was first detected to have a carbon atmosphere. So that's what happens to supernovas. They turn into neutron stars. Hopefully I can get this little bit of a video to play, and hopefully it'll play with sound. We'll see, since I'm playing it this way.
Where do most of the elements essential for life on Earth come from? The answer? Inside the furnaces of stars and the explosions that mark the end of some stars' lives. Astronomers have long studied exploded stars and their remains, known as supernova remnants, to better understand exactly how stars produce and then disseminate many of the elements on Earth and throughout the cosmos. Cassiopeia A, or Cas-A for short, is one of the most intensely studied of these supernova remnants. A new image from NASA's Chandra X-ray Observatory shows the location of different elements in the remains of the explosion: silicon, sulfur, calcium, and iron. Each of these elements produces X-rays within narrow energy ranges, allowing maps of their location to be created. Astronomers also see the blast wave from the explosion in the form of the blue outer ring. X-ray telescopes, such as Chandra, are important to study supernova remnants and the elements they produce, because these events generate extremely high temperatures, millions of degrees, that remain even thousands of years after the explosion. This means that many supernova remnants, including Cas-A, glow most strongly at X-ray wavelengths that are undetectable with other types of telescopes. Chandra's sharp X-ray vision helps astronomers not only determine what elements are present in Cas-A, but also how much of each there is. For example, Cas-A has dispersed about 10,000 Earth masses worth of sulfur alone, and about 20,000 Earth masses of silicon. The iron in Cas-A weighs about 70,000 times that of the Earth, and astronomers detect a whopping 1 million Earth masses worth of oxygen being ejected into space from Cas-A, equivalent to about 3 times the mass of the Sun. Chandra has repeatedly observed Cas-A since the telescope was launched into space in 1999. It will continue to do so, revealing new information about the dense core left behind in the center of Cas-A, details of the powerful explosion, and specifics of how the important debris is ejected into space.
And that was put out by NASA with the Chandra X-ray telescope.
Very nice.
So, of course, not all images of the sky are optical. We have different types of telescopes: Hubble, Chandra, Spitzer, and they all look at the sky in different types of wavelengths. So Hubble looks at the optical wavelength. Chandra here looks at X-rays. Spitzer is infrared, I believe. So usually they'll combine the three views to make one beautiful image. But a lot of that material that we just saw there can't be seen optically. It has to be seen through X-rays. And there again, those clouds, millions of degrees, even after thousands of years. Okay, so let's go on a little bit farther, I guess. Some other targets that are in Cassiopeia are some nice double stars. There's Eta Cassiopeiae, one of the finest double stars in our sky, also called Achard. The primary star is yellow gold, and the secondary star is the red-orange color. Then you have Sigma Cassiopeiae, fainter and much tighter than Eta. Very difficult to split. You need lots of magnification to split that double. Both a blue to a blue-white color. Then we have Iota Cassiopeiae. It's a triple star system, and the colors there are yellow, pale, lilac, and blue. So we're talking about Arctrid is right here. There's the W shape. Arctrid is right. I don't know if you can still see my mouse. Yeah, I guess you can. Sigma Cassiopeiae is over on this side right here. And then Iota Cassiopeiae is up here, off the top corner of the W. Then you have Rho Cassiopeiae, which is a yellow hypergiant. It's one of only a few known in the galaxy. Although it's 10,000 light years away, it still has an absolute magnitude of minus 9.5, which would make it 500,000 times as bright as our sun. And a few other really nice targets. Gamma Cassiopeiae, which is a spectroscopic binary, appearing blue or blue-white in color. The primary star actually spins very fast at about 432 kilometers per second. Now, a spectroscopic binary means that you can't see the second star, but what we can see is the star shifting from the red to the blue as the star moves closer and farther away from us because another object is pulling on it. It also has two visual companions, components B and C, with a temperature of about 25,000 Kelvin and a mass about 17 times that of our Sun, and luminosity 34,000 times of our Sun, and an age of only 8 million years. Gamma Cassiopeia is the youngest, most luminous, hottest, and most massive of all the 5 stars that form the W. And then we have Rakba, which is Delta Cassiopeia, which is an eclipsing binary. So one star passes in front of the other from our point of view. Rakba is the primary component. Every 759 days, the star's system's brightness drops by just 0.07 magnitude when the fainter companion of the 2 stars passes in front of it. So all the doubles are not necessarily optical doubles. Spectroscopic ones, we know those because a star is farther away, so it shifts to the blue end of the spectrum. As it approaches us, it moves into the red end of the spectrum. And these eclipsing ones, one star actually passes in front of the other, and we can see a dip in the brightness, similar to what would happen if a planet passed in front of that sun. And that's about all I get to say about Cassiopeia. My talk, anyway.
Where's camera we own?
Alrighty,
Yeah.
we'll hop out of that, and I'll stop presenting.
Pretty cool.
Made it through anyway.
Cassiopeia.
Yeah, it's
Lot.
pretty interesting. It's an interesting constellation for sure. Really quite visible. I mean, once you pick it out, the W or the M shape, it's just like the Big Dipper. It stands out all the time then. And it's circumpolar too, just like the big. So it's always up in our night sky, always circling around Polaris. So from there, we're going to take a little talk to Michael's going to give us a talk now.
Oh, okay.
Mike, I guess, sorry, not Michael.
It depends on if you're mad at me or not.
Christopher, I've heard that a few times.
Pull this up. We should have Cassiopeia.
We do.
Dude. Awesome.
So it's pretty easy. If you can see my mouse, my arrow.
Yes.
Yes.
Good. So the 5 stars that make up the W, 1, 2, 3, 4 down here, and 5, like Chris showed. There's Seguin, Rockenbach. I think Rockbach. Is that how you say it? We're having a Rockbach.
Concert, yeah.
Gamma Cassiopeia. Come down here to Shadar, and then up to Calf. And that makes the 7 stars that make, or the 5 stars that make up the W, and then there they are with the lines so you can see. So when you're looking in the sky and you're saying, where's this W? After the previous picture, when you draw the lines in, it's pretty easy to tell where the W is. So if we were going to start looking around at objects in and around Cassiopeia and how to find them, this is a high-def picture taken by NASA that I grabbed, and I started labeling some of the easier objects to find right in, and I call this the inner Cassiopeia. This is all parts of the W. Cassiopeia, the constellation itself, is far bigger. It reaches far to the north, excuse me, and goes down to Perseus and Andromeda and so on. This is just the W section of it for now. So as we practice, when I zoomed in before, I had to let it settle for, say, 5 seconds or so, which I shall do right now. And it should be coming in clearer. And you should see, distinctively start seeing some of the objects where the labels are. You're showing up there now, Paul? Pretty steady?
Yep.
Awesome. So there's the first 2 stars in the W, Seguin and Rakba. So if you drew a line in between the 2, a straight line in between the 2, starting at Rakba and working your way up, almost a fifth of the way just off the center of the line, the first thing you come across is Messier 103. And you'll recognize that in your scope when you see it. It almost looks like, when I look at it anyway, a miniature version of the Big Dipper. A little tiny version of the Big Dipper that fits right into the single eyepiece. And it's a nice little open cluster to look at. If you kept following straight between the 2 stars, about halfway, you come across NGC 654. which is a pretty big open cluster. It's pretty easy to find. And it takes up a lot of eyepiece. Like, it's a nice open cluster. It's tight, but it's still very simple to find. Now, if you took in between the two, you were drawing a line between the two, and you found this NGC 654. If you drew a perpendicular line off of that and come straight down, you'd almost land right on top of NGC 663, which is another nice big open cluster just below it. So it's very simple to find. You draw a line between the two, about halfway is NGC 654. You draw a perpendicular line off of that, come straight down, and you'll find NGC 663, two big open clusters. Now, if you were to go between those two clusters and just to the left of using a reflector telescope, anyway, you'll come across this IC 166. And IC 166, I wrote this down here somewhere, is another nice open cluster. I just found it. I thought it was going to be like more in the vicinity of a dwarf galaxy. I've never looked at it before, but it's pretty easy to find in this photograph, and it's going to be a target for me. But as it turns out, it's a tight open cluster. So we'll back out just a little bit and let it settle. You let me know when it looks like we're settled there, Paul?
Yeah, it looks good now, Mike.
Perfect. So you come down from those two stars and you go from Rakba to Gamma Cassiopeia, Gamma Cassiopeia, which is the star up here. You go up to it, and right beside it in your field of view will be a beautiful emission and reflection. It's actually a reflection nebula, sorry. IC 63 and IC 59. IC 63 is this little one here, and it looks like it's almost a ghost's head. And then just off it is IC 59. Very easy to photograph and very easy to find. Excuse me. If you were taken and you were looking again between these two stars, Rakba and Gamma Cassiopeia, if you drew almost a triangle between the three, or you went in about 1/3 of the way and come straight down, you will find NGC 436, another nice open cluster. And then just down from that, if you're looking real close, and everybody will recognize, I'll zoom in and let it settle, is NGC 457. And that one is your upside down ET cluster, or owl cluster. Here you can see his two bright eyes. The arm come out this way, the arm come out that way, then down the leg and the feet. Everybody recognizes ET when they see him.
That's a favorite right there.
He's pretty easy to find. I'll zoom back out. Another way that I find him is I come down from Seguin through Rakba and draw a straight line. And then when I see this NGC 436, I know it's just below that. So these are just a few items that are right in around the W itself. I'm going to shift over here further. And if you were to draw a straight line between Gamma Cassiopeia and CAF, about halfway across, you'll run into a nice open cluster right here, NGC 129. And again, you'll know when you see it in the sky, it's a really nice tight cluster against the background stars. This is shot against the Milky Way, and you can see how many stars are in the background, and these clusters are standing right out in front of them. So, and again, if you just kept following from that cluster over to the last star, CAF, about halfway between the two and come down perpendicular, you run into IC 10, which is a beautiful dwarf galaxy. Right here. And I zoom in a little bit. When I first looked, I thought it was a cluster. I have seen this one, but it's actually a galaxy, and in front of the star, the stars are behind it showing through it. So it's pretty cool. We'll zoom out and let it settle for a second. There's one more I wanted to show in the tight version. That should have settled out by now. If you go from Calf back down here to Shadar. And I forget the name of this one, Chris Aknar or something like that. Aknar, I think you said.
Archer?
That's it, Archer.
Archer, yeah. Archer, sorry, yeah.
You go between those two and draw a perpendicular line down, and guess who you run into? You talked about him. NGC 281, the PACMAN Nebula. I'm sure I think you photographed that one, Paul. Beautiful shot.
Yeah.
So that's just one way to find your way around the W itself, that are very close, just follow between the stars and off to the left or right. From a straight line between two stars, you're going to run into one of these clusters somewhere, and it's just gorgeous to look at. If I was to move out a little bit, excuse me, and say, okay, this is the close to the W, but you see this stuff way over here that's off the end of it. They're pretty easy to find. The first two are the Heart and Soul Nebula. This is the Soul here. This is the Heart here. And right in the Heart, there's a nice open cluster, this NGC 1027, right in here. It's a nice open cluster to look at. You'll see it before you see the nebulosity. Really, you got to start photographing it, I guess, before you see the nebulosity. Use a proper filter, you might pick it up. I've never looked naked eye at it, but I have seen NGC 1027, and you know that the Heart Nebula is right around it. Another one is if you take Gamma Cassiopeia, come down through Rakbar and draw a straight line down, you move into Perseus and you run into the double cluster right here. Everybody knows the double cluster, beautiful in a pair of binoculars, nice target, easy to find. When you come down, draw a straight line down and you run into it, you'll know it's the double cluster. You can't miss it. We talked about the PACMAN Nebula and there's numerous others. If you go up from Shadar through Calf, and just off the edge of this chart is M52. And M52 is a nice open cluster. You just draw a straight line and it's about the same distance. Unfortunately, it's not on this map. But, it's just a matter of drawing a straight line and following the same distance, just like we do when I'm looking for M81 and M82. I come up through the Big Dipper, hit the two stars, go the same distance on the other side, and I nail M81 and M82. If we wanted to spread out even a little bit further, you can see Cassiopeia. The W sits here, but the whole constellation goes up and around like this, all the way up almost 20 degrees from the pole or zenith, and then comes all the way back down. And I don't know why these astronomy groups that decided where the boundaries were put it the way it is, because it's got a big notch out of here on the bottom. And if it came down to where the rest of it is, then the double cluster would actually be inside Cassiopeia instead of inside Perseus. Maybe they just wanted to make sure that Miriam, the star, was part of Perseus, and they wanted to leave it in that constellation. Again, you look off the end, you can see the Heart and Soul Nebula over here. But if you come down to Rakba again and almost draw a line straight down, and you go nice and slow, about the same distance between these two stars straight down, maybe a little further, you're going to run to M76, which is the little dumbbell. And again, you'd be surprised. It's little, but you can spot it. It's pretty easy to find.
Mm.
If you come down from Cassiopeia Gamma down through Shadar and almost follow and then up to Calf and come down, if you drew a straight line down from that V, there's two galaxies down in here that are pretty easy to spot. NGC 185 and 187. There's two galaxies down in the lower portion. They're just up above M81 or M31, M110, and M32. So if you drew a line, and we've all drawn our line this way from Cassiopeia to find the Andromeda Galaxy, there's another way you can do it. You take Gamma Cassiopeia, Calf, and Shadar, take that V and draw a straight line off the V, and it'll point you right at M110, M31, and M32, and about halfway between the two, you'll find this NGC 185 and 147, two little dwarf galaxies in there. If you saw that I showed you earlier, it wasn't on the map because the photograph wasn't big enough, but there's Shadar, there's CAF, and if you went the same distance at the same angle, it'll take you up to one M52, which is the open cluster over here. So this is just some of the stuff, that are right inside the W Cassiopeia itself. And then if you drew like a small circle around it, some of the stuff within the area of that small circle, there's all kinds to look at. Almost as much as, what's that famous one we hear? Cygnus.
Leo.
Leo, yeah.
Yeah, Leo.
But no, where it's lays right in the Milky Way, the northern Milky Way, there's a lot of objects in there that just pop right out. And the star field in the background, anywhere you look around, that is incredible. It's just a massive, thick bunch of stars in there everywhere you look. There was one that I forget the name of it that was in here. I wrote it down. IC 1795. I forget where it is. You can look it up, I suppose, but it's the Fish-Head Nebula. Is in there too.
The Fish-Head is the tip of the heart.
Oh, it isn't. Okay, that's what it was. It was right up in here, the tip of the heart.
Yeah.
Okay, because I think I did have that on a slide here, right there.
Yeah.
So yeah, there's the third one. You got the heart, the soul, and the Fish-Head Nebula, all right, bang, bang, bang. So I just wanted to show you it's pretty simple to find your way around Cassiopeia once you see the W in the sky. And there's all kinds of objects that are right off. If you do the lines between the stars, all kinds of objects right off the lines. And then you start doing sweeping circles around it. And it's just an incredible sky up there. So,
Yep, very well. A great spot to spend some time with a pair of binoculars even. Like you don't need a telescope to enjoy that field of view right there. For sure.
It's amazing. Just amazing.
And you're looking at such a rich part of the Milky Way that all those colors we see there as well. It's amazing to capture all that with your eyeballs. And you will see colored stars with your eyes for sure.
You do.
I'll get a question here. Lisa says, which of these do you recommend for small telescopes or binoculars? Which of these? The whole area, really, yeah. NGC 457 should be an easy target with binoculars. I mean, just below that as well, of course, the double cluster, like Mike mentioned, isn't Perseus, but it's just outside the area of Cassiopeia. But some of those double stars that I had mentioned earlier are all great targets. But if you just pan anywhere along that area of Cassiopeia, you should be able to pick up lots of stuff.
Oh, yeah.
I mean, the nebula is going to be a little tougher to pick out, Paul, right? The nebulosity is not going to be as easy to pick out with binoculars and even small scopes. But which ones would you guys suggest? Any particular ones you'd suggest for
Well, I mean,
telescope?
some of the easiest stuff with binoculars would be the double cluster for sure. You might have a hard time making out ET, I think.
I found a pair of binoculars and it wasn't as difficult as I thought once I spotted the two eyes.
Yeah.
Okay.
There's a ton of open clusters in there. So if you move your binocular just slowly in and around anywhere on that W, there's just like clumps of open clusters.
Yeah.
So you just let your eyes relax and you'll see all kinds of stuff there.
Yeah. Awesome.
Right in around the W, there's at least 10 open clusters. If you followed the lines between the stars, you're going to hit at least 10 open clusters. And they are distinguishable from the background sky, even in a pair of binoculars.
Yeah.
Yeah.
All right, thanks, Mike. We're going to get to Paul's topic right now, Paul's discussion, because we're in the 20 to 9 right now, and we want to get through everything about Cassiopeia first. We've got some other things that we're hoping to add to the end of the program here. But let's move right into Paul now, because Paul's got some amazing captures to show us for sure.
Oh, all right. So what I'm going to do is I'm just going to just do one quick little stellarium present. So
if you want me to pin your topic, Paul, just let me know. Otherwise, the three of us are down the one side.
Not a bad idea.
One pinned, okay.
Yep. Okay. So for those who are just getting into observing the night sky, some of the easiest things to find to start with, like what Mike and Chris have talked about and what I'm going to talk about, is finding some of those constellations that are easy to find first. Because when you look up, you're not going to see all these things. Apparently, you're going to be standing on the ground, and you're going to try to get your bearings first. So the first thing you want to do is try to find the North Star, which is, I'm circling it here. So when you look up in the sky, you're going to, and you look north, you're going to see Ursa Minor, which is the Little Dipper. And then at the very tail of the Little Dipper is Polaris, which is what we call the North Star. It's not true North Pole, but it's as close to the North Pole as you're going to get. And it's always there. It primarily doesn't move to the naked eye. So once you find that star, you can either look immediately to your right or up or down. And then when you look for Cassiopeia, which is that M shape that you see in the sky, and this time of year, in fact, right now, it's up quite high in the sky if we were to go outside and it wasn't cloudy. In fact, it's up at about 55 degrees. It's actually higher than Polaris. So it's a really good spot now to look at Cassiopeia because it's so high in the sky that you're away from all the atmosphere and all the stuff that bad seeing and that affects the most. And you'll be able to get a really, really good view of that. If you take Cassiopeia and then look right back to Polaris and keep going, you're going to run right into the Big Dipper, which is right here. And of course, it looks just like a Big Dipper. It's probably the most recognized constellation in the sky, or actually it's asterism, but part of the constellation, but in the sky, but that you'll see. So if you were just to focus on those two constellations, or three, if you want to include Ursa Minor, there's not a lot in Ursa Minor, but there's a lot in and around Ursa Major. There's a lot in and around Cassiopeia. And because they're circumpolar, and what the fellows were saying, that simply means that as things rotate, these never set to a degree. Like you'll always see them in the northern hemisphere where we are. They always show themselves. So you don't have to wait for winter constellation or summer constellation to see these. They're there all the time. So if you're just getting started out, it's a good thing to practice it because you'll recognize where the north is. Once you recognize where north is and you start to understand these constellations that kind of whirl around Polaris and those ones, and then you can just start looking at those constellations, and they're really, really nice to see. So if you're standing on the ground and you're facing north and you look up about 45 degrees from our northern perspective, where we are here in New Brunswick, you're going to see the North Star. That star will stay there pretty much all night. In fact, if you're shooting time lapses of star trails, that's the one that you're going to point at, and everything will circle right around it. So anyway, so I just want to give a quick look at that and show you on Stellarium kind of how to find those things. So that is that. Now we'll get into just a few photographs. And now Mike and Chris have pretty well pointed out where all of these things are. So I'll just give you a little, whoops, it's gonna show it on that screen, isn't it? There we go. Make that big. There we go.
There he is.
So let's just get right back into, I'm just looking for this one here. So this is what everybody looked at. So this is kind of your starting point. So as an astrophotographer, or as somebody who wants to take wide field shots of the night sky, you can actually take a camera, and if you have a tracker where you can track this thing, for a couple hours, and take 1 minute or 2 minute shots and stack them all up at the end of it, you can actually make your own image of what Mike showed you, just like this. And a lot of these things that you see in hydrogen alpha, if you don't have a special filter or you don't have a modified camera, they won't show up quite as red and brilliant as this, but they will show up. So you'll be able to actually take pictures of Cassiopeia. This one here, you can probably get all of this target with probably about 20, maybe even I'd even try it with a 35 millimeter camera lens. So if you've got a kit lens that goes 18 to 55, which most of us do, just kind of set it around 35, look through your viewfinder and see if you can get the W shape in there. And if you can get all of it in there, just zoom out so that you can get just, a fair bit of space around it. Then you can actually take a photograph just like this. So it's not that difficult to do, but you definitely would want a star tracker because you need to get some time on that camera to be able to get enough light, stacked up so that you can actually see some of these items pop out. So that would be the first thing. Now, having said that, shrink that back down, and we'll go to our next photo, maybe. So this one here is called the Bubble Nebula, and this one is called, the catalog name is NGC 7635, and it's a hydrogen alpha rich nebula. And the interesting feature on this one, of course, is the bubble, which is pretty apparent when you look at it right there. So in order to get a photograph like this, you have to have typically, a refractor style telescope, which is the one that you see Galileo, the straight long tube telescope. And it doesn't have to be big. In fact, this one here, I used 100 millimeter refractor to get this shot, 105 millimeter. So it's a very, very, average size telescope that most people have. So that's what I used to get this particular shot. And I had to use a special filter to get the nebulosity to pop out like this. If you have that filter, the time that it takes you to get these objects are extremely less than if you don't have the filter. So that's one of the targets in and around Cassiopeia that are for astrophotographers are a lot of fun. Whoops, going the other way, I guess. This one here is the double cluster. This one here is easy to get. So you can see that there are two clusters, NGC 884 and NGC 869. This is an absolutely wonderful binocular target. But it's one of those things that it's relatively easy to photograph this with a camera on a tripod and a lens, because this is really one of the brighter clusters because this is very naked eye in a dark sky. I live in Hampton, and I can just look up and point right at this cluster. So if you've got a camera that's like an f2.8 or an f1.4, the lens where it's where it's very light friendly, you can get shots like these. Zoom into about 200 millimeters or so, and you can get a nice shot of this double cluster. The next one, of course, we just saw this, and the ET cluster, and again, it's a star party favorite. Every star party I've ever gone to, I don't think there's an astronomer out there that hasn't shown the ET cluster because it's kid friendly. And when we were kids, when I think we still are being astronomers, I don't think we'll ever stop being kids, but the kids love this. And for those who don't know who ET is, and a lot of the up-and-coming kids may not know about this, he came out and came to life somewhere in the late 70s. So before the late 70s, he wasn't called ET because he never existed. He was called the Owl Nebula, or the Owl Cluster, and it's very, very easy. So forget about his arms and his legs and all that. Just look at the two big eyes that you would see in an owl, and the body, the head and the body right here, and he's sitting on a branch. And that's where the Owl Cluster got its name. Again, another very, very easy target to find in binoculars, and a wonderful target to shoot. And actually, this is one of the few things you can look at through a telescope in a dark sky with a nice aperture and actually be able to see some of the colors that are in that. It's a beautiful cluster. Next up is the PACMAN. We just talked about that. And again, this was called, the catalog is NGC 281. And before PACMAN came out in the 70s, I think it was 70s PACMAN came out. Of course, this wouldn't have been called PACMAN back then, but it is now, and it's been adopted since the 70s. So, and it looks like that little thing that wants to go beep, 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 or whatever the sound was, and he's just munching away on whatever he can find.
What was that?
Again, I think I
think you gotta get back to an arcade. Waka 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 waka.
This one is another great target to shoot. Again, it's a hydrogen alpha target, and it makes for an absolutely wonderful photograph. All right, and this one here now, Mike was showing. Actually, I'm gonna go ahead a bit because I want to show something else first. There, so there's the Heart Nebula. Mike showed the Heart Nebula earlier, and the telescope I had didn't have enough wide enough field of view to pick up the whole thing. And this is a huge nebula. It is huge. So you really need a small telescope to be able to have a wide enough field of view to be able to pick it all up. But that's a portion of the Heart Nebula. And in the center of the Heart Nebula is a star cluster. And this portion of it's called Melotte 15. The actual Heart Nebula itself is called IC 1805. And it has a lot of components that people love to photograph. And this is the fish head that Mike talked about right here. So this is the part of the heart that you couldn't see in the photo before, but it's the part that actually sticks out like almost the handle of the heart, or the part, if you look at a heart where it joins down on the longest part on the bottom. This is a part, and when you blow it up and look at it, again, all associated with hydrogen alpha, looks like a fish. So thus the name the fish head, and this is IC 1795. So that's one portion of the Heart Nebula. Another portion of the Heart Nebula, if I can go this way, is right here. So that cluster that we showed you a moment ago in the center of the Heart Nebula, this is a much higher resolution version of it. And this is a beautiful thing to photograph. It's just full of some reflection going on there, lots of hydrogen alpha gases, and emission nebula. Beautiful cluster in the center of that. You can see that cluster in the Heart Nebula with a pair of binoculars. It's absolutely gorgeous thing to look at. Also, if you have a wide enough, this is an old photo, so excuse the lack of quality on it, but this is the Heart and the Soul Nebula together, and this was shot with an 85 millimeter lens on a tripod and a camera. So, but I had a special filter in there so I could get the red nebulosity to look like that. And but there is an absolutely wonderful thing to capture, and that cluster that Mike talked about on the edge of the Heart Nebula sits right there, and it just stands right out. It's just, hello, look at me, I'm a cluster. Just absolutely gorgeous. So that's the Heart and the Soul Nebula.
Perfect timing for that one, Paul.
What's that?
Perfect timing for that one.
Yes, just because it's all fine. But with the Rosanna segment, we're going to do a special one for that too. And this is the Soul Nebula, and I've often looked at this and I thought, again, it's an absolutely wonderful nebula. Again, rich in hydrogen alpha, and like Mike and Chris were both saying, it's in the heart of the Milky Way, so it's got a very, very rich star field. No matter how or where you look, you can't avoid stars. There's so many. But the nice thing about it is they're so varied in size that there's so much to look at. But this one, I've often wondered, why did they call it the Soul Nebula? And I think I figured it out. But Mike or Chris, can you guys tell me, or do you actually know the answer?
No.
No.
No? Okay.
Soul fish, or a soul of a foot, or
The soul. Yeah. Or maybe it's from Korea. I don't know.
I'm a soul man.
Soul man, yeah.
Soul Man. Now, I think what it is, and I could be wrong, but if you look at it, it looks like a fetus in a womb. So if you look at the head, this would be the head of the baby.
Yeah.
This would be the body, and this would be the heart. This is the soul of a human before it's born. So I'm thinking that's what it is, but if it isn't, I think I've romanticized it enough to think that, hey, I could use that.
I don't know. Looks like a pretty scary monkey to me. Like there's his eyeballs right there, 1, 2, and there's his big ugly teeth. Here's his ear over here. I call him the monkey nebula.
A monkey
Like a boot to me, that's the soul.
There is a monkey head nebula, so like that's.
Oh, it is. Oh, there is. Okay.
Yeah. So anyway, so I think that kind of covers what I wanted to show, except for one thing, very briefly, that this image of the double cluster and this image here was actually taken with when we were doing one of our live stack shows. And for those who don't know what live stacking is, it's just basically when you're out there with a telescope and you got a little video camera on the end of it, you can shoot a whole bunch of frames. And so what happens is you take a picture, it keeps it there, takes another picture, puts it on top, takes another picture, puts it on top. So if you ever got into the point where you want to invest some money into a telescope system and a little, laptop so you can run it, you can actually do live viewing like this from the comfort of your house, inside your home, and be able to see the color images rather than going out with a telescope and just seeing the gray smears. And we do this as much as we can on the show. I think you've all seen it for those who are watching. But this was actually an image that was taken from a live stack. So so if you want to do or get into imaging without getting into a lot of the technical software and all that stuff right away, live stacking is a very simple thing to do. Just takes a little bit of ingenuity, but you can sit there all night long and enjoy hundreds of targets in color in the comfort of your home.
Awesome, Paul.
So
Trudy says if they don't know ET, tell them it's Wall-E. I guess
Wall-E.
that's a good one.
Oh yeah.
Yeah.
Newer kids know it is Wally. I was going to say.
And Rob Dara says, I think you are right, Paul. It is also associated with the Embryo Nebula.
Okay.
Yeah.
Okay. Well, it makes sense to me anyway.
Yeah, it does.
It does.
Awesome
So anyway,
shots.
so those are wonderful targets that when you get into photographing the night sky and you're just starting out and you don't want to try to figure out where all this stuff is, just take a pair of binoculars first, go look around Cassiopeia, get a small little telescope, look around a little bit more for other stuff. And then when you're ready to start taking some pictures, you've already got a real good idea where all kinds of great targets are, all in around one little constellation.
Awesome. Great presentation. Thank you, both of you.
Yeah.
Awesome pictures. And all of those are for sale. Everything has a price. You know something, folks, we're into 8:57, but if you folks don't mind, like we're really enjoying the program here tonight, so I wouldn't mind us carrying on for an extra 10 minutes, guys, 10, 15 minutes. We'll get our Rosanna's Fun Facts in there, and we've got some photos to show. Mike has a pretty cool little Mike Guyver item that he wants to show us about. It's really it's about losing weight and enjoying astronomy at the same time. I'll leave it there. Going to keep everybody in suspense. Let's quickly go to a few photos.
Losing cash and enjoying this.
Yeah. Let's go quickly to a few photos, just so that we can get through. Because I did promise I was going to show photos, and I don't want people to not get a chance to bring their photos up on the screen. So let me share my screen again here. I'm going to go back to number 3. If you guys can hang on, we'll be about 15 minutes long tonight. That'll be about it, if everybody's okay with that. What else are you doing tonight, right? Tomorrow's a holiday, I guess, or something.
Oh, yeah, I forgot about that. That's right.
Family day.
And a snowstorm.
Yeah, that's right. So, yeah, what else are you going to do? Okay, here's a picture from Pat Bacon. Sent this one in. You guys able to see that okay?
Yeah.
Yep.
Okay, great.
Oh, nice.
So Pat Bacon said this is a moon pic, was taken back on January 25th. She said, noticed this waxing gibbous moon at 86%. Had interesting rings, she says. So it's pretty cool.
Yeah.
Awesome.
Like
Thanks,
Nibiru.
Pat. Yeah. Shh. You're not supposed to talk about that one yet. Stefan Picard sent these ones in. He says, hi, Chris. Was out last evening on February the 11th to take some nice captures of the Orion constellation and various targets around it. Such a beautiful but chilly night. I don't think has been a clearer night than last night for viewing, and was amazed at the outcome of my shots. He says, I took 16 shots. I'm not showing 16 here tonight, but with my Canon DSLR, and found what appears to be a shooting star in 2 of the shots. Now, this could be a satellite in one or both. They were shot about 15 minutes apart. I looked at some websites that track satellite tracking, and I don't believe they are there, but can't say for absolutely sure. I also know that there's Alpha Centaurids happening this time of year, which is a meteor shower, of course, but again, can't say for certainty, as the direction they are coming from may not be where they are supposed to originate from. Do you mind showing them back to back to show the unaltered image followed by the same image that's labeled? Can you, Mike and Paul, weigh in? So, guys, just
see it up at the top right.
Yeah, there's the labeled one. Orion's
Okay.
up there. There's Orion Nebula, and this is one he's calling a shooting star or meteor.
Can we zoom in a little on the meteor, Chris?
I think we can. Get us over here to the right part of the
Right.
screen.
Over.
Oh, I see it there. Yep.
My guess is the satellite,
That's probably a satellite. Yep.
Yeah.
because it's not tapered really at both ends,
Okay.
right? A shooting star will taper; it'll go bright and then taper off. And you can see here in the beginning of the shot, there's a little bit of movement where the shutter's settling in as the satellite's focusing in.
Okay.
I think it's a satellite.
Okay. Awesome.
I've taken pictures of the ISS that look like that.
Okay.
And I know that's not the ISS, not that time of night, but
Right.
that's exactly what my shots of the ISS look like.
All right. Let's go to the next one. So here's this next shot. And of course, Orion's right there, nice and big and bright.
Oh,
Look at the,
that's very nice.
there's the one there that he's captured. So we can do the same thing here. We can zoom in on that one. Get us down here.
Yeah, satellite.
Satellite
That's
again?
my-
Yeah. Okay.
Yeah.
Yeah, so there's so many of them up there now too, right? I mean, and going to get a whole lot more very quickly.
Yeah. Thank Mr. Musk.
Thank you, Mr. Musk. That's right. Over 12,000 are going to be up there shortly for everybody. So, okay. Those are great photos. Thanks very much, Stefan. And Trudy sent in these ones. Hey, she says, almost missed this because I figured it would be below the tree line. So I only went out with binos, but then there it was. Quick scramble to get the camera, zoom lens on, tripod and remote together, and out the door. By that time, I had a small amount of deck space to work with to get around that tree. And it was dropping so fast, it was hard to take time to focus. Taken at 6:02 and 6:05 cropped photos. So this is the first one, 6:02. Of course, that's a 1.4% moon. Mike and I wrote observing that the other night.
You guys are looking at exactly the same moon.
Yeah.
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 26 hours old. Mine had it flipped left to right just because it was passing through the refractor scope, but there's her close-up
Oh, beautiful.
shot. Nice.
Wow.
You can start to see detail in the bottom end there, the crater right in that bottom area.
Yeah.
About 5 o'clock. You can really see that in a pair of binoculars. That
Right in there.
there's a
Yeah.
crater there trying to pop out.
Yeah.
It's really cool.
Even last night with the 4% moon, there was some detail in here. I was really surprised to see some
Yeah,
crater detail.
it's nice to get that though. That's such a thrill because usually every one of those that I've seen, you've got that really nice blue to pink sky.
Yeah.
For some reason it's just the sky just colored so beautifully.
Yeah.
Yeah, nice.
It's a nice shot. It's a tough shot. It's a nice challenge every month. That was a 26-hour-old moon. Trudy says she's going to try for something a little bit younger next time. That's always the case, but
only about 15 minutes from the time we spotted it to the time it was below the horizon.
yeah,
Yeah.
yeah,
That was real quick.
it does move very quickly. Surprising how quickly things move. This one came in from Lisa.
That's cool.
Lisa's on our thing here
So
tonight.
is that fun again?
She says, Lisa Fanning, this is an oldie but a goodie. We haven't had clear skies for weeks here in New Jersey, she says. So I've been revisiting some of my favorites. The recent new moon had me revisit this Earthshine photo that I took last October, she said. I kept the vignetting because it reminds me of a snow globe. It's cool, yeah. This was a 2% illuminated moon.
Nice.
I wonder what that's.
Yeah, me too. She says,
Where's that? When was it?
I'd say it's October. She said late October of last year.
It was going into the trees by the looks of it, so it was probably relatively, you could kind of, if you knew the exact date, you could go to the stellarium and you can find out what star that is.
I wonder if it was Venus.
She's on Facebook here with us, so she might be able to comment here shortly.
Yeah,
It might be Venus, yeah. She says, thanks for bringing us clear skies when ours sometimes aren't. And that does happen sometimes, but we're glad to be able to offer it for sure. And finally, we got this one from Jamie. Why not? Nice, beautiful shot here. She says, hi, here's my submission for the week. Tonight's crescent moon. Used my Celestron 10x50 binoculars on a tripod, smartphone adapter, and an iPhone 8. Isn't that cool for just a tripod and binoculars? 10x50 binoculars, look at that.
Just a few years ago, it would have taken a telescope or a really good camera lens to be able to do what he just did.
Yeah.
Yeah.
The technology is so freaking good now.
Yeah, she did.
Great.
She did a great job on that one. Looking forward to the show tomorrow night. She said so. That was last night she sent me that. So awesome.
Yeah.
Love those photos. Really enjoy being able to show other people's work on this program. And if you'd like to show your work, just send your photos into Sunday Night Astronomy Show at gmail.com, and we would be happy to focus and highlight them on our next week's show. So thanks everyone for sending those in. Really appreciate that. And I'll go back to stop presenting. Brings back to full screen, and we're going to carry on. So we're now at 9:06, but we still got. I guess people are still hanging around a little bit, so let's keep going.
Good. All right. So we want to do Rosanna.
Yeah, let's do Rosanna's talk, and then we're going to end up with Mike's little Mike Guyver segment. Real quick, Mike Guyver.
All right. So let's see if I can get.
What's that?
Life-saving equipment.
There you go.
Life-altering, at least.
All right. So let's see if I can get this in. Okay. So to this tonight. Quiet facts. Oh my gosh.
The sound of silence.
The sound of silence. Hello, darkness, my old friend.
Gotta love a live show.
Oh my goodness. Where did that go? There we go. There's what I did. Yeah, we don't want that one. We want this one.
Rosanna's Fun Fact.
Hey, thanks, John Paul.
Hello, how you doing? Good to see you again. And Rosanna has sent us a very, very, very timely and fun fact. In fact, she says this fun fact for Sunday is for Valentine's Day. So today is Valentine's Day, and those romantically inclined may have some thoughts that are turning to gold, perhaps a lovely gold trinket or some sort of has been purchased for your significant person. Gold is actually rare on Earth. Platinum, commonly considered to create a more exotic, expensive type of jewelry, is actually more plentiful, 6 times more so. So like all the heavy elements on the periodic table, there isn't much gold to be found. If all the gold that was mined in the human history was formed into a solid cube, it would measure only 21.3 meters on each side. So interestingly, because gold is so dense and heavy, most of it has sunk to the core of our planet, which is interesting. So Australian geologist Bernard Wood estimates that 99% of Earth's gold is buried thousands of miles below our feet. So how did the gold get there? So basically, here's a little breakdown of what the Earth looks like right from the exosphere right down to the inner core of the Earth. So how did gold get there? Scientists believe all the gold on Earth formed in a supernova and neutron star collisions that occurred before the solar system formed. In these events, gold formed during the R process. Gold sank to the Earth's core during the planet's formation. It's only accessible today because of asteroid bombardment. Hard to believe. So why do we love gold? There are lots of reasons. There we go. There are lots of reasons, but one main one is that gold is the most non-reactive of metals. It refuses to share electrons with oxygen, and thus, unlike iron, which rusts, copper develops verdigris, or silver tarnishes and goes black, but gold remains gold. So how much gold is in space? With the development of the spectroscope, eventually gold was identified in a gaseous state in the sun. Scientists have calculated that the sun contains almost 2.5 trillion tons of gold, enough to fill Earth's oceans and more. It seems like a huge amount But remember the size of the sun, proportionately speaking, that's only 8 atoms of gold for every trillion atoms of hydrogen. So the Psyche asteroid, located between Mars and Jupiter, contains a mother lode of metal, including gold, iron, and nickel. The estimated value is about $700 quintillion. Enough of that was eventually distributed amongst, enough that if it was evenly distributed amongst all 7.6 billion Earthlings, each person would receive $92 million. Wow.
Wow.
So asteroid mining may be in our future. In January 2026, an uncrewed NASA spacecraft is scheduled to arrive at Psyche. I say, we should unionize.
They're belters.
So Paul Sagan stated, we are all made of stardust. If the Valentine's Day gift you have for your sweetheart has gold in it, then you can honestly say it is a gift from the stars.
Waka waka waka.
Waka, waka, waka. And that is this week's.
She
Awesome.
was turning green with envy.
Rosanna's Fun Fact.
Awesome.
Yay!
Hey.
Again, that was an absolutely wonderful
That's cool.
fun fact this week. I really enjoyed that one.
You know, and a continued thanks to Peter too for sending us those sound clips in the background. That
Absolutely.
every time. Thanks so much, Peter, for all that.
They work. We may not, but they work.
Oh well, can't have it all. Okay, so now we're going to go to a quick Mike Guyver segment. Mike has found something out just today, I believe, because he sent me a little note saying that he had a special Mike Guyver segment for me to present, and he had a special present there for me as well. But I don't know how special it is, but it is kind of neat. So I'm going to let Mike take it away. So go ahead, Mike.
So as of January, my wife has decided that the little bulb I got going on down here might not be the healthiest thing. And she wanted to see what I thought about changing my diet. So no pop, no chips. You know, that's been taken away from me. I don't, no ice cream, you know, no French fries. So what did she get for me besides things that don't taste very good? Because, you know, if you shop in the outside aisles of the grocery stores, 90% of it doesn't taste good. If you shop where all the sugars and stuff are, that stuff tastes good. Anyway, one of the items she decided to get for me was yogurt. I don't even know what, you know, I've thought, okay, that's that sour tasting ice cream stuff. It's not, you know, but I'll try it. Yogurt. But as I was doing my thing and eating this little teeny, like, and that's the smallest cup in the world. I don't know, who do they make these for? Midgets? Like, anyway, as I'm looping through this, I'm looking at the size of it and I'm going, I wonder. And so me being me, anybody that has 2-inch eyepieces diagonals, guess what? You got yourself a 2-inch dust cover for your telescope.
A redneck
It
dust
goes
cover.
in, it locks into here, and doesn't fall out. So you can use Activia yogurt cups to make yourself a dust cover for your 2-inch diagonal. The other thing I did is I took a second one because, of course, I had to eat more than one. Because look at the size of this thing. I drilled 6 holes in the bottom of it. I dropped 3 little desiccant bags that I had from some electronics in there. And then I put a little piece of plastic and glued it over the top. And guess what? Now I have a desiccant eyepiece for my diagonals and scopes. So instead of looking around, buying 3D printers, going online and buying yourself some, you know, dust caps for your 2-inch diagonals, or, you know, the end of your scope, right, when you take your diagonal off, go ahead and find Activia yogurt, and you can use that as wash it out, of course, but you can use it as a dust cap. So there's my Mike Guyver segment for today.
Does that come in Celestron Orange too, Mike? Or?
Well, maybe it's Celestron pineapple. I'm not sure.
You know what? You always were saying you wanted everything Celestron orange, and now
Yeah.
you the smell of Celestron orange.
There you go.
Exactly.
Well, Mike's always everything he looks at is has to be related to astronomy of some type.
Listen, if it works and it's free, I'm in.
There you go.
There's nothing better than dual purpose.
Awesome. Okay. Thanks, Mike, for that. All right, folks, we're into 9:15. That's probably going to be our evening episode, I guess.
Before we finish, if you don't mind, I just want to share one more thing. And this thing I'm going to share is for everybody out there. And I just I go out today, and of course I got to buy Mrs. flowers because it's Valentine's, and I've kind of extended the feeling because I had a bunch of coffee and I'm all hyped up now. So I wanted to extend a nice flower to everybody tonight, and to everybody I'm offering you a rose.
Yeah, awesome.
So there is a rose for everybody watching tonight, and you can look up to Orion, and the Rosette Nebula is up there. We've already talked about the heart. We've given you that, our soul, and here's a rose from me to all of you folks up there.
What a mush. I'm tearing up. Talk amongst yourselves. Awesome, Paul. Nice way to end the show.
I can close my Rosette Nebula picture now.
Yeah, we have it too. All right, and on that note, I guess we're going to call it an evening. Thanks very much for everything out there, folks. So in closing again tonight, our special thanks again for your continued support out there. Thanks again to Rosanna for her continued contributions to our show. We really do appreciate it, Rosanna. Thanks so much. Thank you as well to all the great folks at Astronomy Plus for sponsoring our weekly program. Remember, too, we do love getting your photos, so send them into SundayNightAstronomyShow@gmail.com, and we'll be happy to include them on our next broadcast. We also looking for suggestions for future topics. I am making a list, actually, of people who have suggested topics for our shows, and I've got to bring them up with these two guys because we are going to try to squeeze them in. Next week, I'm actually going to do our first of our segments, which is Where Are They Now? So it's going to be it's all about spacecraft that are out there right now performing missions. And next week I'll be doing the first topic about that. Instead of what's new in space, every second week we'll switch out with what's out there right now in space. But anyway, we always looking for new topics for future shows because these shows here are educational, hopefully for you, and we're trying to bring you topics that might interest you, of course. So if you do have ideas for future shows, please send them into the same address, SundayNightAstronomyShow@gmail.com, and we'll be happy to put them on our list and bring them to you. Also, we asked that if you enjoyed the content here tonight and you joined us from YouTube, please consider giving us a like and subscribing to our channel. And please let your family and friends know as well that we are here every Sunday night at the same time, same bat channel, same bat time. To help educate and entertain you a little bit for the evening on the night sky. So for now then, I guess from Mike and Paul and I, happy Valentine's Day, everyone out there. Take care of your sweethearts out there. We wish you all clear skies, and we hope to see you again here next week at the same time. And remember, as we like to say here, guys, keep your scopes pointed up.
All right.
Have a great week, everyone. Thanks for joining us. Take care. Good night.